And also I want to note that this is our new range profiler. So this is in preview in the version that just shipped, 19.2. And you're probably saying, Jeff, I've seen you do this talk like 1,400 times. This looks very similar. What are you talking about? This is new. It actually is all new, and that is because it's all programmable now, or user configurable, I should say. And the idea here is that rather than us kind of only giving you access to certain metrics, and we had our user metrics section in the past, but rather giving you only access to certain metrics, now you can actually define what are in these different sections yourself. So obviously we're going to pre-populate it with ones that we think are helpful, but as you learn more and more about NVIDIA GPUs, you're going to understand a combination of one, how the GPU is utilized, and then two, specifically how your engine behaves on the GPU. So you're going to start to gather your own collections of metrics that you find particularly helpful for either graphics or compute debugging. And so the idea there is that now you can create your own sections. Now you can have whatever you want in terms of the data. And the section files are really easy to work with. Here's an example one. This is actually the SM section, so right here. So you can see here, let's go to the top. You can see here I've got the SM active, that's right there at the top right over there, and then the SM min max delta, and kind of alternates column 2, column 1, column 2. And so this is basically how I define this top section up here. We call this the header. And so this is what's displayed when I haven't opened anything up. Then inside of one of these, I can go ahead and have a number of different visualizations. So for instance, in this one, I've got this table of metrics. So what I've done there is I've basically said, okay, I want a table. I've got 17 rows, and here's all the metrics that I've got available there. So it's great just to be able to, again, lay out what exactly metrics you find interesting. We've got even more complex things, so we still support things like our visualization of the full range profiler, the full GPU throughputs. So those are still available. But then also, again, all these different things are fully configurable by you, the user. The other thing that it enables is you might have noticed this little thing right here. You say, okay, well, what's that little yellow triangle is? And I open this and I say, oh, okay, so it's got this thing called a warning. It says a large number of draw calls have been detected. Now, obviously, this is a bit of a contrived example, but this is our rules capability. And what you can do is you can basically sample any one of the values that's in one of these sections and then construct a rule about it. So for instance, in this rule right here, I said, okay, what's my draw count, what's my dispatch count? And then I said, if my primitive count is greater than 5,000, say I've got a large number of draw calls, and then I just did the simple message of, which is greater, the number of draw calls or the number of dispatches. Now, you may think that, oh, well, that silly little draw call count, is that really helpful? But it may be. You may have a budget of only a certain number of draw calls in your frame, and you want to know that right off the bat, right? Right there, you can find out instantly. So obviously, this scene is a little bit more than that. So what I'm going to do is I'm going to up that to 15,000, and I'm going to save it, and you notice that everything's already updated. So what we do is we keep track of watching those files. We've got a write watch on those files. And as you make edits to these, it's instantly going to be reflected in the UI. So you've got a really rapid capability of iterating on these sections, so that it really allows you to richly design what you want to be in the shader view. I'm sorry, in the range profiler view. The other thing we have the ability to do is configure this on the fly. So as you add different sections, you can enable them and disable them. So like say you're looking at a rendering problem, more of a draw call problem and not a compute problem. Well, fine, just take all of your compute sections, disable those for now, and then you can have all of that real estate available for just your compute problem and vice versa. So it's nice to be able to kind of configure those on the fly. All right. So now what we're going to do is going to start to try and understand better how to analyze the data here. So we can see here I'm going to basically look at my largest render pass. That's one of the great things about Vulkan, is they have this concept of a render pass where I can determine exactly what draw calls are going to be related and what draw calls are going to be interesting to look at. And actually, I'm going to go ahead and confess I forgot to run something beforehand. So this value is a little bit higher than it should be. And the reason why is that I have not fixed the clocks on the GPU. So you may have heard a blog post from Louis Bavois when he talks about the peak performance analysis method. And one of the things you want to do, make sure you do, is you want to make sure that you fix the clocks before you run the profiler. And normally in DirectX, we actually take care of that for you. We don't have that capability quite yet in Vulkan, so I forgot to run my little applet that fixes the clocks for me. So you can find it online. He actually links to it from his peak performance analysis blog post. He links to the article that talks about how to do that clock setting. And basically, it's just you create a DirectX 12 object and use DirectX 12 to fix the clocks. All right. So we're going to rerun the range profiler. those values look much more reasonable. And now the key is they won't vary as much. That's the really important part. All right, so the first one we're going to look at is this first section right here. One of the capabilities of the profiler is as you select different ranges, it will actually set the current action to the last range in that action. And so therefore you can figure out exactly what's happening. So you see here on this second one, which we'll talk about in a minute, this is when I was doing my G-buffer pass, and this is when I'm doing my shadow pass. And so when I first come in, I'm going to start to look at, the first thing you want to look at is your throughput values, your SOL values, your speed of light values. And by the way, we are going to change that term very shortly to be throughputs because people don't understand what SOL means and they think they're out of luck. So anyway, so when you look at these values, you can see instantly I've got what VPC, which is called our viewport cull unit, that's at about 34% of its throughput. L2 is about 31%, and PD, or primitive distribution, is at about 22%. And actually, this is making a lot of sense to me. And the reason why is what I'm doing right now is I've got a shadow pass going on. It didn't go to my last one for some reason. That's not updating. There we go. That's not updating for some reason. Interesting. Dan, I think we found a bug. For some reason, the current target view is not updating. Anyway, so this is my shadow pass. And so what's happening here is I'm basically doing, taking all that geometry, running it through basically on a view coming from the position back to the light, and I'm figuring out exactly where I'm in shadow, where I'm not in shadow. And so, okay, I'm submitting a whole lot of geometry. I've not got very complex shaders going on, simple transforms. I'm not doing any, coloring and any cool lighting effects and everything like that. So it makes sense that if I'm going to be bound based on viewport cull, which is where it's going to take all of the geometry and cull and clip it to the viewport, and primitive distribution, where it's going to basically take those draw calls, chop them up into smaller bits and smaller packets, and send it to the shader units, it totally makes sense that that's what I'm going to be able to see there. But you're probably wondering, well, why am I culling so much? And this actually is not necessarily a bug, but it is potentially a performance issue. And so what I can do is I can come over here and say, well, let me look at what's happening specifically with the viewport cull unit. And it looks like I've got just under 10 million input primitives and just over 1 million output primitives. And so we can start to see why my performance is limited here. My viewport cull unit is crunching like crazy, trying to make sure that only the things that are within the viewport are actually going to go to the rest of the pipeline. And so while I didn't have time to actually do any optimizations to this one, but I can tell you that typically what you'll want to do is you'll want to either do some object level culling. And so the idea there would be maybe objects that are outside of some sphere of influence, if you will. Just go ahead and cull those out. Don't even have them be part of the calculation when you're doing your shadow buffer. But that you can also look at doing some LOD on your geometry. So you can either, even with the closer in geometry, but definitely with the further out geometry, based on where the location is in the scene, just go ahead and use your lower LOD. Now, you might say, oh, well, that's going to impact my shadow quality, and it definitely will potentially have an impact, especially for the closer in geometry. But note that a lot of the times with shadows, you tend to do a little bit of a blur to it and things like that, so you're not going to get lots and lots of sharp details, unless, of course, you're using RTX and doing actually ray trace shadows. Those are going to be super sharp and they're really cool. But typically when you're using shadow maps, you're not going to get the sharpest of shadows. So it actually may not be a visual anomaly if you happen to use that method. So I'd encourage you to do that. But again, now we're able to see by simply looking at these SOL values and looking at my viewport cull and my PD, that's where I want to spend my time optimizing, thinking of ways that I can reduce the amount of culling I'm doing and therefore result in faster throughput.